Now, the second kind of concept that I want to talk about is related to diffusion, but it's called good old osmosis. All right, so we got diffusion and good old osmosis. Now, osmosis, that is similar to diffusion, but it deals only with water. All right, so with diffusion, you have particles that want to spread out from high concentration to low concentration. Think of osmosis as the motion of water, but water wants to spread things out. Water spreads things out. So in other words, let's take an example here. We have another little container, and in the middle of that container we have a membrane, right? And on one side of the membrane, let's say that we have potassium, right? A bunch of potassium ions. All right, we have a whole bunch of potassium ions on the left side and just a few on the right side. In between all those potassium ions, we have water, okay? But in this case, we have a difference, all right? This membrane that separates the two sides will not let potassium cross. So I'll just put like a big X through potassium. But it will let water cross. All right, so that membrane will let water cross it, but it won't let potassium cross it. This is what's going to happen. All right, so water wants to spread things out. There's not a lot of water over here, but there's a lot of water over here on the right side. Which direction is water going to want to move? Well, it's going to want to spread all of these molecules out, so water will move from the right side to the left side if it can. Now, if we can imagine that the little walls of this container are flexible, they can be made out of rubber, something that can expand and contract. What's that going to do to the shape of this container? Well, water's going to move from the right to the left. This side's going to get smaller, and it's going to move on this side, so that side gets bigger. And we have our little membrane there. But now, if you look, the concentration of those potassium ions are just about equal. There wasn't a motion. There wasn't any movement of the potassium ions due to diffusion. There was only a motion of water that spread those guys out. Okay? Now, this can have some pretty big consequences depending on what's going on. If we take, let's imagine we have a flexible bag of particles. All right? This flexible bag of particles could be a cell. So let's imagine we have a little cell right here. And cells, you know, they're going to contain a bunch of little particles. Let's say they contain particles in about this concentration. Now let's say we put that cell in a solution where the concentration of particles on the outside of the cell is about equal to the concentration of particles on the inside of the cell. All right, these could be ions, sugars, fats, whatever. All right. Now, what's going to happen here is water going to move inside or outside of the cell? No, in this case it's not, because things are equally spread out on both sides, and you're really not going to have much motion of water. You're going to have little osmosis, and we're going to have no change in the size of this cell. This solution on the outside is called an isotonic solution. All right, it's kind of the first example. Now the second example, let's imagine that we have our cell with all the little particles on the inside, right? But on the outside, we have a solution that has a very low concentration of particles. Now these particles can't move across the membrane really easily, but water can, and it's going to. We're going to have some osmosis. Because water wants to spread things out, there's a higher concentration on the inside, water is going to flood in. Okay? And when water floods in, it's going to cause that cell to get very large, increase in size to kind of spread things out. This solution that had the low concentration, that's called a a hypotonic solution. Okay? In this hypotonic solution, that's exactly what happens to your blood cells when you drink too much water. Let's say you have a huge intake of water. That's going to dilute the amount of solutes in your blood. Okay, that's going to cause your red blood cells to be in a hypotonic solution. Water's going to rush in, and those blood cells are going to get bigger. The opposite of a hypotonic solution is when you have a blood cell, or any type of cell, that's in a solution that has a super high concentration, right? That's called a hypertonic solution. In this case, water again is going to want to spread things out. Okay? So what happens is you have water moving from the inside of the cell to the outside. That causes the cell to do what? It causes it to like shrivel up, get smaller. Okay, so that there's an equal concentration on either side. And that's exactly what would happen to a cell if it's placed in a solution that has a higher concentration of particles or solutes on the outside versus the inside.